Let's take a look at this Lesson 1 application problem. Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use a graph to find when the value of the guitar will be $60. Okay, so the purpose of this exercise is just to practice using your graphing calculator. Now, yes, you could find the solution without the use of a graph, but again, the purpose here is just practice. Now, if you have a graphing calculator, use the directions posted on this sheet. This video is for those of you who do not have access to a graphing calculator. I'm going to show you just a different way you can do this without having to go out and buy a graphing calculator. So again, if you own one, it's best just to follow the instructions listed here. They're going to be the most effective and efficient, but if you don't have one, continue watching. So the first step they went through was to write a function to model the growth of the guitar, and that's shown with f of t. And you can see here it says f of t equals a times the quantity 1 plus r to the t, where a, our original amount, is $12,000. That's what the guitar was purchased for. Our rate of growth is 0.14, and the time is unknown, right? We know that f of t is going to be set equal to 60,000, right? So we're asking ourselves, when is the value, the y value of this function, when it's 60,000, what's time going to be? Okay, so again, we have this expression 12,000 times the quantity 1.14 to the t, and we want to know what the value of t is when this expression is equal to $60,000, and that's where that trace function comes in. But again, if you don't own a graphing calculator, you don't have access to that application. So this is just one option you can do instead. So I went on the internet and I looked for free applications, and I found Desmos Calculator. It's just www.desmos.com, and it pulls this up. It's just a blank graph. So I'm going to type in our equation, which is f of x equals 12,000 times the quantity 1 plus 0.14 to the x. You'll notice that I changed it from f of t to f of x. That's just a personal preference, okay? And it's graphed the function for me. So notice my window, and the window is just the part of the graph that you can see, is already where I want it to be. And that's because I practiced with this website before doing this video. So you can use the scroll function on your mouse to kind of scroll in and out. You can see right now I'm scrolling out. Values are getting larger. I can click on a part of the screen and drag it upwards if I want to move the window down. Likewise, I can click and then drag downwards to move upwards. So you'll have to play with how the window works a little bit. Again, I can zoom out if I want to get a good idea of what this graph looks like. Okay? So I recommend that you play with this window a little bit. Now, as you know, our question is, at what point will the value of the guitar be $60,000? So in other words, when is time, or x, going to equal $60,000? Now, this website doesn't have a trace function per se, but what I can do is I can click on the graph, and you can see towards the bottom of the screen I've got this kind of purple dot that's following. This is kind of like the trace function, and again, all I did was just click on part of the graph and start dragging my mouse around, and the values are changing as I drag my mouse around. Now, we want to know the exact value when y equals 60,000. What is x going to equal? I'm just going to type in f of x equals 60,000. Okay, and you can see it's populated this line, this orange line that represents y equals 60,000. I'm going to just click on the intersection of those two lines, and you can see it placed a point there. And I can see that my function intersects or hits 60,000 when x is equal to 12.283. Okay, so that would be my answer, 12.283 or 12.29 years. And that's the answer they have in that textbook page. So, again, I know that was kind of a lot of steps, but this is, again, just a way to work around not having access to a calculator that has that trace function. So, again, what I did was I graphed my function, and then I asked myself, okay, I know that my goal is to figure out when the function is going to pass through that 60,000 mark. So I plotted a line right at 60,000, and then I just had to click. And, obviously I didn't have to click perfectly. I just had to get it in the general area, and the application understood that I'm trying to find where the intersection is, okay? And again, you can trace on this. If I zoom in, if I just click on this point, you can see it's hit 60,000, 280 is the X value. And if I just drag the mouse from right to left, it'll show me the values as I drag in each direction. So this is one way to kind of work around not having the trace function available to you. It's definitely easier when you're dealing with smaller numbers. However, I hope that this has been kind of an ample explanation of just one way to work around not having a TI-83 or 84 at your hands. And again, it's going to take some playing around and some practice before you get comfortable with this, but keep at it. I'm sure you'll get it. All right, thanks guys.